In this example, what we want to do is use a normal probability plot to assess whether the sample data could have come from a population that's normally distributed. And specifically, we're going to look at this as much as we can by using the TI-84, but then I also want to show you some things with StatCrunch. As anything goes in life, there's probably multiple ways that you can get a process done, and sometimes one way is easier than another. And I think personally that this particular problem is easier to do with StatCrunch, but I do want to show you what you can do with the TI-84. So to start with, we would need to type all of this data into our calculator, and I've already done that here. Underneath Stat Edit, you can see all that data has been typed into List 1. So if you'd like to follow along, pause the video and put this data into your list. Now next, we're going to go to second y equals to get into plot 1 by pressing enter. We turn it on by pressing enter. And underneath type, we're going to go to the last type, which is the normal probability plot. In which, by the way, the instructions that I'm following are the same as what you see from the text, the technology step-by-step instructions. And so far, we've gotten to this part right here. Press enter to select this plot type. The data list should be in list 1. That's where we put our data. The data axis is the x-axis. We leave that just as it is here. To see it quickly, we can press zoom and the number 9 for the statistics zoom. And we can pretty much observe that this looks like a very linear plot. Now, if the question we're just asking, does it look like it is, does it look like this sample data could have come from a population that's normally distributed? I would say yes, just based off of the look of this normal probability plot. But the choices ask for a little bit more information. So we need to get the correlation coefficient from this plot. And then we need to compare that correlation coefficient to the critical value for 16 pieces of data, which I'll go back up in a second and show you that. Now the problem here is that once we have this graph, we now have to trace to find the values of the observations and the corresponding normal scores. Now again, what we're trying to do is avoid having to do this by hand, right? So I can press trace and I can see this Y value, but now I'm going to have to write that down and then turn around and type that into list 2 so that it corresponds with this X value in list 1. And I need to do that for all 16 values. And I just feel like 16 values is probably a little bit too much to be doing all that right here. So this is where I would suggest instead, let's look at the StatCrunch instructions. So let me see if I can kind of compare these here. I'm kind of overlapping, but I hope you can see through my process what you should do. So I'm going to go ahead and open up this table in StatCrunch. We're going to select graph and the QQ plot. We select variable 1. We do want the correlation statistic. Remember, this is the part that was difficult to find in the TI-84 because it would take a lot of extra just by hand work. And notice that immediately we get the same graph. We see it does still look very linear, and we have the correlation coefficient immediately, 0.996. So again, both technologies are awesome technologies, but I feel like this particular problem is best served with StatCrunch because of the things that we're asked to complete here. So we would want to say yes, that this correlation, or first of all, yes, it does look to be a linear normal probability plot. And the correlation coefficient is 0.996. That will exceed the critical value. Now to get to the critical value, we come over here to the critical table. We had a population size of 16. So the critical value is 0.941. So that's why that value is right here. And because this correlation exceeds the critical value, then it's reasonable to conclude that the data come from a normal population.